Hi, in this video, we will go through the steps involved in downloading this sum model for checking and validating the encoder counts of the rotary inverted pendulum. So as you can see, there is some model named as encoder test. So if you go inside the model by double clicking, you will find that there are two blocks, attenuation block. So each blocks divide the input by the number of counts the encoder is installed. So if you double click on this, you can see that the encoder 1 attenuation count is 40,080. So that is the encoder attached with the DC motor of the pendulum. Whereas the second block has the encoder attenuation count of 10,000. So that is the attenuation block for the vertical arm, which has an encoder attached with 10,000 counts per revolution of resolution. So let's download and check our hardware is working with this model. So I have attached up constant, so there is no point in seeing the simulation output because we will see something, a figure like 0.1. So to download this, click on Tools, Real-Time Toolbox, C Code Generation, select 20sim4C tool chain, and select the sum model as encoder test. Click on OK, click yes. So here we have the 4C tool chain. Select the target template as rotary inverted pendulum. Click on OK. So it will discover the target board which is connected to the local area network. Click on apply. So the block goes green. Now for connection, you can see that the inputs as encoder 1 motor input and the pendulum in, which is the vertical arm. So double click on the motor, connect with motor quadrature counter without any index, click OK. For the second one, connect to the vertical arm quadrature counter. The output we will just connect to LEDs. So select the LED, you can select any one of it, green, and for the second one we will select the red one. Click on apply. Do not connect these outputs with the motor, else the motor will respond in unknown manner. So we have compiled the code, so you can see the configure, connect, compile have gone green. So we go to command block. So the step frequency of the execution of this model is 500. Click on apply. But if we run just the command, so we would be not able to see the output or record the output. To record the output, click on command with logging. So you can select the variable which you want to record. So click on select, you see a long list of variables. So better you can, on the left hand side of the menu, you can select the block and you can record input and output, both of them. So I select the input and output of the encoder 1 attenuate, and for the second one also I click on input and output. Click again the command with log and apply. Now we can download this model and see the response. So we have the pendulum setup here. So after downloading, you have to rotate the arms so that you can see the log output. So I click upload and start with logging. So I will just take the pendulum and rotate this clockwise and let it settle. So here you can see in the plot, this is the encoder 1 input and output, but we are not interested in these outputs. We are interested in this one output. So you can see that this is encoder 2 attenuate input. So it goes till 10,000 number of counts, and the output in revolution we get 1. So that indicates our calculations was correct and our setting of the encoder counts is correct. Now we run the second part of it. So I run this model second time, and this time I rotate the motor encoder and try to bring it at the same point. So here you can see that the input of the motor encoder goes till 40,080 counts, and the revolution count also is coming as 1. The second input is oscillating because while I was rotating the arm, the vertical arm was swinging a little bit. So we can conclude that our setup of attenuation counts was correct, and we can proceed with the next experiment. Thank you.